Okay, we're going to start now on a new topic, which is chapter sequences and series. It's chapter 6 in our textbook, and off we go. It's a great topic, this one. You're going to really enjoy it. We're looking at patterns initially, and then we really focus on a couple of different types. But if we look at we talk about patterns and number patterns, these are some of the fun things we do in maths. There's lots of different types of patterns, aren't there? So we can go, right, what are the next two numbers, of that sequence of numbers? Well, I mean, that's not very challenging, is it? But there you go. But it's certainly a pattern. What we do is we look for what is the pattern so far. Right, that looks like it's being I could be adding 6, but no, it doesn't. So you go, what about times 4? Yeah, times 4. So then I can go times 4, and then times 4 is 400, 512, and that'll do us there. So these are the ones we know. These are the ones we have to. So there's lots of different ways we could go. Well, how about we just square the number in front each time, or we look at the square numbers. This is. So you get to that point there, and what's happening with these numbers? Well, it's not times. Well, that is times 4, so that could just be 64 there, and then 256. But actually, what else it could have been was 1 squared, 2 squared. Actually, I missed 9, didn't I? So if I did want to do the squares, I'd go 1, 4, 9. What's this? That's add 3. That's add 5. So it could be add 7. Could be add 9. Actually, well, they're the square numbers, aren't they? Could be add 2 more each time. So these are all. There's an infinite number of patterns. We could just do a fairly straightforward one where we just sort of do that. And what are we doing? Well, we're just adding 4 each time. We could do this one. We could go, let's add the two numbers in front and come up with, so each number is the sum of the two in front. So the next one there would be 8, then it would be 13, then it would be 21. And this is a very famous sequence called the Fibonacci, which you've probably looked at before, the Fibonacci sequence. Okay, what we're going to do is we're going to look at a couple of different types of sequences, and I'll show you which ones. This one here, where we've got what we call a common difference, and this is called an arithmetic sequence, and this is what we're going to look at initially. Arithmetic sequence, because that has a feature such that any term less the one in front gives us the same number. Any term less the one in front. If you take any term and subtract the one in front, you get, in all these cases, 4. So what we say from that is that we have a common difference. We call that common difference D. So the feature of arithmetic sequences is that they have a common difference. That common difference we call D, and in this particular example, it's equal to 4. Okay, we're going to have a look at those type of sequences. We're also going to have a look at these types of sequences, and in fact, this type of sequence here. These are what we call geometric sequences. Geometric. And they're called geometric sequences. They're what we call, well, if you take any term and divide by the term in front. So do a little division here. Okay, for arithmetic, it was a little subtraction. Sometimes that's negative, right? But here, and sometimes this is negative. But what we're getting, if we divide by the term in front, any term by the term in front, we're getting the same number. And whenever that's the case, when we get the same number, when we're dividing any term by the one in front, what we've got is a geometric sequence. We say that they've got each term divided by the term in front has a common ratio. And in this case, we call that common ratio R. In this case, R is 4. Okay, so that's a geometric. Actually, what's this first one? It falls into the arithmetic category, doesn't it? So we'll give that the yellow highlighter, because if we take any term and subtract the one in front, we're getting 1 each time. So we can say from that this is the counting numbers. It's an arithmetic sequence difference 1. Okay, so that's the definition of an arithmetic and a geometric. There's some famous sequences, but Fibonacci doesn't fall into either of the arithmetic or geometric categories. But what we're going to look at firstly are arithmetic sequences, and we're going to start to look at how do we find out what the 150th term is, and what's the sum of 100 terms, and this sort of thing. because we can do some really interesting maths with this stuff. So with arithmetic sequences, all right, we'll go back. We'll just now concentrate on arithmetic sequences, and as we said, they have a common difference, and that's it. That is the definition. Has a common difference, D. Okay. So some examples, and we've got some up here. But you know, just any time you take a number, let's make a common difference of 6. So it'll be 9, 15, 21. Common difference is 6. Right, let's go the other way. Let's start with -4. Have a common difference of 8. So add 8. Oh, got that wrong. Add 8. Common difference is 8. What about if we start with 12 and we go 7, 2? Right, so now our common difference is negative, and we're going down by 5 each time. So our difference is -5. So there's some. We could go on forever, but you get the idea. That's what arithmetic sequences are. Now what we're going to do is we're going to start to define some things. We've got D as 6. That's the common difference. Sorry, D is the common difference. All right, we're going to let. All right, so U1 is equal to the first term. Okay, U1. UN is going to be the nth term. Right, the nth term. So put a little number in here. U10. So for example, for e.g. here, U10 is referring to the 10th term in the sequence. Right, UN, we know that D is equal to the common difference. And that's probably enough for us to get started. So if we start to have a look at generally now at an arithmetic sequence. Okay, so we'll call the first term will be called U1, and the second term, yes, it's U2, but let's use it in terms of U1. What's happening to the second term? Well, we take the first term and we always add the common difference, don't we? So the third term will be U1 plus D plus another D, so that'll be U1 plus 2D. So rather than write third term now, I'm just going to write U4, and that's going to be equal to U1 plus 3D. Keep adding D each time. Just add D plus D plus D to get the next term. We just add D. Righto, well let's jump here and see if we can progress to the nth term and what it represents. Well, if we have a little look here, we're always starting with U1, aren't we? So it'll be U1 plus, now what's the relationship here between this number, the fourth term, right, in this case the third term was U1 plus 2D, the second term was U1 plus 1D, the fourth term U1 plus 3D, so U1 plus 1 less than this, and minus 1D. So this is our nth term formula, the first formula. Very formula-based topic, this one, but we're going to derive them, and that's the formula there for the nth term of an arithmetic. It will appear in your formula booklet, so you do not need to remember it. However, it'll be tattooed on your brain in no time because you use it a lot. So therefore, what we're going to say is the nth term, the nth term, therefore, the nth term of an arithmetic sequence is U1. Right, what we'll do is we'll write it in UN kind of format, is ... UN equals U1 plus n minus 1D. Remember, n represents the number of terms, or the number of a particular term. All right, so let's look at a couple of examples, then we'll close on this YouTube. So there's some examples here. Just going to pinch them out of the text. I'll pause and write. Righto, so I've got a couple of examples here. Find the 12th term of this sequence. Well, let's firstly establish that what we've got here what sort of sequence we've got. Now, okay, I've given you the heading arithmetic sequence and blah, 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 but in reality, we're going to have to establish the type of sequence. Take any term, subtract the term in front. Any term, subtract the term in front. So we've got a common difference here of 6. Our first term is there, U1. So the 12th term, we're going to use this formula here, which is given to you in the formula booklet. UN, the 12th term is U12. U1 is 13. N is 12, so 12 minus 1, 11. D is 6. 13 plus 66 is 79. So the 12th term of this sequence is 79. So we've gone to it. We could have just gone 13, 9, 20, right, we're adding 6, 31, 37, kept going, and we'd have got eventually to 79 by the 12th term. However, using this formula, we're getting there fast. Imagine the 1200th term or the 800th term. Of course, this is going to be for low numbers here. Yeah, we could do it manually, but we're looking to use maths, and what we found here. This is the beauty of maths, isn't it? We look at a pattern, we discover a pattern, we can see something now that we can predict, write a formula for. We can use that formula to save ourselves some time, which is always a good thing, and that's what mathematics does, saves you time, using rules and formulas that you've found. Maybe you've proved some yourself, maybe they've been proved before, but that's what we're doing. Find an expression for the nth term. So this will be in terms of n now. So let's get into this as, all right, what I always want you to do with these screencasts, when I'm going through examples, if you can pause the YouTube, do the question yourself, and then press play and then check whether we match up with our answers. That's always a really good way of using these lessons. So here we go, expression for the nth term. So UN equals U1, which is 13, so we can put that in there. N, we don't know what N is, so we're going to put N minus 1 there, and D is 6. All right, so this is 13 plus this 6. All right, we can think of that 6 as just being there. All right, it's got the same effect. We're used to seeing it there, though. That's why I wrote it there. 6n minus 6. And if we simplify this, we get 6n plus 7 as our nth term expression. Now, if you think about that, all right, that's our nth term expression. All right, put in 12 for that. 6 12s are 72 plus 7 is 79. So here's an nth term expression which simplifies this for this sequence. Simplifies this general formula for the nth term of an arithmetic to it specifies it specifies it to this particular sequence. So 6n plus 7, sub n in for the 100th term, 607, 200th term, 1207, right, etc. Second example, again, look, find the number of terms in this sequence. Establish that it is, in fact, an arithmetic, which it is, but in this case we're going down by 3. Any term minus the term in front, 81 minus 84, 78 minus 81. So minus 3 is our common difference. How many terms in the sequence? This is our last term here, so we want to know what un equals 12, what's n equal to. If you want to pause and have a go at this, then I encourage you to do so. So un, we're going to again use our un formula, which is un equals u1, which is 84, plus n minus 1d. Now in this case, we know what un is, it's 12. So we can sub 12 in here, 84 in there. D we also know, it's minus 3. So when we put everything in that we know, we're just left with n to solve. N will give us what number term 12 is. So if we just solve this equation, it's going to be 84 minus 3n here, minus 3n plus 3. So 12 is equal to 87 minus 3n. All right, if we keep working this through, we get 3n is equal to 87 minus 12, which is 75. And therefore, running out of room, n equals 25. So therefore, 12 is the 25th term. Okay, we got there fast, didn't we? Number of terms in this sequence. So therefore, there are 25 terms in the sequence. Just answering the question quite specifically, which is always very important. All right, last example. In an arithmetic sequence, U9 is 48 and U12 is 75. Find the first term, the common difference, and then the 20th term. Right, well, let's find the first term first. This is a different type of questions that we've been given two. We've got two clues here. 9th term is 48, the 12th term is 75. Let me show you how we go about this. The 9th term is 48, so U9 is equal to 48, but we also know that U9 is equal to U1 plus n minus 1, 8d. Remember, this is n, so n minus 1 is 8. So U1 plus 8d is equal to U9, which is equal to 48. We're told that U9 is 48, so in fact, it might be more sense for you to just actually write that as 48 out the front. So 48 is equal to U1 plus 8d. What is this one? How do we write that one in terms of U1 and d? Well, in this case, 75 is our 12th term. I'll write the U9 out here. Maybe that's the 12th term is 75. Right, we're told that. But I can write this as U1 plus 11d. Now what we have here are a pair of simultaneous equations. And you know how to solve simultaneous equations. We've looked at them in the past. And these types are really, really easy to do by elimination. So in fact, I'm going to rewrite them U1 plus 11d in the other order, and also just change them so that I've got my U1s and Ds over the left-hand side. Now, if I use elimination by substitution, what I'll get is U1 minus U1, that's gone. 11d minus 8d is 3d. 75 minus 48 is 27. So I get d is equal to 9. And if d is equal to 9, I've now got my d here. 8 9s are 72. 48 equals what plus 72? 48 equals what plus 72? So that'll be, so this U1 is going to be negative, isn't it? Because that's 72 and that's 48, so that's 24. So U1 will equal minus 24. So we'll just check that through with our second equation. 75 is equal to minus 24 plus 99. And that makes sense. So there's my first term is minus 24. My common difference is 9. Now, what is the 20th term? So now with that information, we're going to find out what U20 is. And U20 is U1 minus 24 plus 20 minus 1, so 19 times common difference of 9. So minus 24 plus 172, is it? 19 nines, 10 nines are 99 nines are 10 nines and 9 nines are 81. Sorry, it's not quite right. 171. 29s are 180, subtract. So minus 24 plus 171 is 147. Would that be right? 171 minus 24, 151, we have 147. So the 20th term is 147. So we use simultaneous equations, because we can create from this information here two equations with U1 and D as the unknowns. Use elimination in order to find what U1 and D are. Solve those two. We've just solved those simultaneous equations, got our solutions there, and then we use that information in order to find the 20th term. So quite an involved question, that one. Brought in quite a few components. I'm going to close there, and we will be working on Monday. We'll be working on exercises 6A, 6B, and 6C. So I'll see you then.